Before we dive in, do me a quick favor and hit that subscribe button and give this video a like. It really helps the channel out, and you won't want to miss what we've got coming up. Meet Kenji. He's a project manager, but his job is more like conducting one of the most complex symphonies in the modern world, a multi-billion-dollar infrastructure project. For decades, a job like this meant an army of planners, schedulers, and coordinators, all desperately trying to prevent a cascade of delays and massive cost overruns. The complexity is almost beyond human scale. But Kenji's approach is a little different. He stands before a holographic interface, a chaotic web of tasks and dependencies representing a massive bridge construction. He simply says, Orchestra, status update. Goal, Phase 1 completion. 30 days ahead of schedule. Identify all critical path risks and propose optimized resource allocations. Kenji isn't talking to a person. He's talking to Orchestra, an agentic AI system. Now, don't think of this as a single software tool. Think of it as a team of autonomous, intelligent agents, each with a specific job, all working in harmony. So, how does this actually work? At the heart of the system is the prompt engineer and goal decomposition agent. When Kenji gives that high-level goal, get ahead of schedule, this first agent takes that simple command and breaks it down into thousands of smaller, actionable tasks. It's like a master planner creating the sheet music for every single instrument in the orchestra. This detailed breakdown is the foundation for everything that follows. Without this step, the goal is just a dream. With it, it becomes a plan. Once the plan is laid out, the agents get to work. We see the scheduler agent start analyzing the project timeline. It instantly spots a potential disaster. A critical shipment of high-strength steel is scheduled to arrive during a week with a high probability of heavy rain. Heavy rain means all crane operations would have to stop. This is a classic project risk that could cause a domino effect of delays. The scheduler agent doesn't just flag the problem, it acts. But here's where it gets really interesting. The scheduler agent doesn't know about weather patterns or shipping logistics. So it practices multi-agent collaboration. It sends out a request for help to other specialized agents. The logistics agent immediately springs into action. It queries an external, real-time weather prediction agent to confirm the forecast. Simultaneously, it contacts the supplier's own shipping agent to check their inventory and negotiate a new delivery date. In moments, the agents agree to move the delivery up by 3 days, landing it perfectly in a clear weather window. Problem solved autonomously. But the challenges keep coming. A new alert flashes on the screen. A specific type of welding robot is showing a much higher failure rate than expected. This is where the system's ability for self-improvement kicks in. The maintenance agent, whose entire job is to monitor equipment health, notices this pattern. It doesn't just report the problem. It investigates. Using a technique called retrieval augmented generation, it pulls all the failure logs, cross-references them with the manufacturer's technical specifications, and pinpoints the root cause. A consistently faulty cooling pump in that model. The agent doesn't stop there. It automatically orders a new batch of upgraded pumps. It schedules preemptive maintenance for the entire fleet of those robots to prevent future failures. And crucially, it updates the project's central risk log. This new information is then sent back into the central system. This is the feedback loop. The system learns from experience. It now knows to keep a close eye on this specific pump in this robot model on all future projects. This knowledge is stored permanently, a concept called state persistence. The system doesn't just solve a problem once. It gets smarter forever, all on its own. So, with all these AI agents managing logistics, scheduling, and maintenance, what is Kenji's role in all this? He is the human and he is the conductor. He doesn't need to play every instrument, but he sets the tempo, he listens for harmony, and he makes the final, crucial strategic decisions. The AI is brilliant at logistics, but it flags a complex union rule conflict that requires human negotiation. This is where Kenji steps in. He handles the uniquely human element in the negotiation, the empathy, the strategic compromise. He is not in the weeds. He is focused on the big picture. Looking at the display, Kenji reviews the agent's work. He sees the steel shipment has been moved. avoiding the storm. He sees the robots are all scheduled for repair before they can cause a major breakdown. He sees the entire, incredibly complex plan has been He clicks. Approve. The project is now on track to finish not 30, but 32 days ahead of schedule. This is the power of Agentic AI. It represents a fundamental shift from using AI as a passive tool, like a calculator, to collaborating with AI as an autonomous team member. This system is designed to automate not just individual tasks, but entire complex processes, all while being governed by human oversight and values. The morale of the story is this. The next evolution of AI won't just be about smarter tools. It will be about more capable teammates. For leaders like Kenji, the future isn't about being replaced by AI. It's about learning how to conduct an orchestra of intelligent agents. This frees up our human potential to focus on what we truly do best. Strategy, creativity, and empathy. The future of work is a collaboration. Thanks so much for watching. If you found this explanation helpful, please hit that subscribe button and turn on notifications so you don't miss our next video. See you in the next one.